In this video, I'm going to introduce the cross product. Now, the cross product, similarly to the dot product, is a multiplication of vectors. And it's called the cross product because instead of a dot, we give it this cross symbol. And what that essentially means is, also unlike the dot product, we get a vector as an output rather than a scalar. So given that we have a vector output, we need both a direction and a magnitude. So I've drawn out here, or written out, this equation here, which is the magnitude of the cross product. And it is it's similar to dot product as well in the way that it's the magnitude of both vectors multiplied by a trig function, which in this case is sine. And then by definition of the cross product, the direction of that vector is perpendicular to A and B. And so there's no way to really prove this direction mathematically. We kind of just define it as the cross product is perpendicular, and that's just the way it's defined. So what this looks like is this picture here, where we have A and B, and they're in a plane, so a flat plane, and we have an angle between them, and then we have this vector, resultant vector, which is perpendicular to both of them, A dot or A cross B. So, and I have these symbols here to show that these are 90 degrees. So one thing to notice is this vector is pointing upwards, and that's good, that's perpendicular, but some of you might wonder why the vector isn't pointing down, because that's also perpendicular. So how do we know if it should point up or down? Well, the answer is we can use something called the right-hand rule to determine the direction that the vector should go. And to do that, we have to take note of one thing, which is this angle has a direction to it as well. I'm measuring the angle from A to B. If I wanted to do another angle, I could measure it from B to A. So there's a direction to it. So let's look at A to B and use our right-hand rule to determine the direction. The right-hand rule is called the right-hand rule because you can use your right hand to solve for the direction of your resultant vector. So how we do it is we curl our fingers like this, like we're gonna do a thumbs up, and you curl your fingers in the direction that your angle is moving from. So I'm going from A to B, and so my fingers are pointing from A to B. Then the direction of my thumb is the direction that your resultant vector goes. And so that's one variation of the right-hand rule. As you see, there'll be more later on, but for now, this is all you have to know. So then if I was going from B to A, like this arrow shows, I would flip around and my fingers would curl this way. I should point this way. So then my thumb goes down, and then our arrow points down. And so this would be B cross A. Okay, and that's the right-hand rule. So let's look at these vectors for a moment, these two different vectors. So remember our dot product was commutative. So we're going to look at some properties of the dot product now, or the cross product. But the dot product was commutative, meaning that you could take A dot B and that's the same as B dot A. In this case, A cross B and B cross A are not the same. They're opposite. So we could say this is not true, but they're the same magnitude, they just have opposite directions to them. So we could put a negative here. And so we have this relation where the cross product of A dot cross V is equal to the negative of B cross A. And we call this anti-commutative. Okay, and so that's just one property of the cross product. Now let's look at some of the behavior of the cross product, specifically looking at the magnitude. So the direction is always perpendicular. That doesn't change, but the magnitude does change. And it changes based on the behavior of our sine function. So we did this for the dot product as well. We looked at the behavior of cosine. So let's look at sine. So if theta is between 0 and 180, their cross product, I'll just go sine theta, is positive, which means therefore that the magnitude is positive. And this makes perfect sense because we know that vector magnitudes always have to be positive. So if your vector magnitude is negative, then you have a problem. But since this is between 0 and 180 is always positive, then that checks out. What if theta is 90 degrees? If theta is 90 degrees, sine of theta is equal to 1. And therefore, A cross B magnitude is just the sum of the individual magnitudes. So that would be a situation where you've got A and B, and they're 90 degrees from one another. So if you're measuring from B to A, or A to B, I mean, basically we're looking down on this. So if you do your right hand rule, you're curling your fingers this way, and your thumb is pointing straight at you. So this vector is going to come straight out of the page. And we use this symbol for that. But anyway, this 90 degrees means that the magnitude is a maximum, which is exactly the opposite of what the cross or the dot product was, because the dot product at 90 degrees was 0. What if theta is 0? Well, it's the opposite of the dot product again, because sine theta is 0 at theta is equals 0, whereas cosine was 1, and so the magnitude is 0. One more thing to note is, in the case of these angles and our wanting our magnitude to be positive, we always take the smaller angle between two vectors. And what I mean by that is, if we have our angle convention where this is 0 and this is 180, if you have a vector here, we don't take this positive angle here. We would take this angle and say, I don't know, maybe that's 120 or something like that. You would take the smaller of the two angles, otherwise this magnitude would be negative, and we don't want that. So that's a small introduction to the cross product, finding some properties of it, and I will do some more mathematical work with the cross product in the next video. Thank you for watching.